Now, we know the harm that some gases do to our planet, and whilst nature has its ways of clearing the atmosphere of carbon dioxide and more, it does it really slowly. So scientists have been trying to find ways to speed it up, and Kevin Keen's been finding out how.
Some of the world's most fertile soils can be found around active volcanoes. When lava rapidly cools, it crystallizes and forms solid rock. Over time, as the rock is broken down, it releases calcium, magnesium and potassium into the soil, creating a nutrient-dense environment. And now scientists at Undo are working with farmers to spread the dust across their lands, where it not only acts as a fertilizer, but aims to capture tons of carbon. It's spread at no cost, paid for by carbon credits from big companies like Microsoft and British Airways. And Ryan says it's an important contribution farmers can make to lowering their carbon footprint.
So natural weathering is something that's been happening all around us for millions of years. Scientists estimate something like 1 billion tons of CO2 a year is being removed from our atmosphere through that. And we're just asking the question of how can we speed that up? And the answer is by powderizing the rocks.
So just tell me, in the most basic way, how this works.
So we are taking silica rocks and spreading onto farm fields. So as it rains, the rain is pulling CO2 out of the atmosphere, dissolving into the rainwater, into carbonic acid, and as that acid falls onto the field, it's reacting with the rock, breaking down the rock to form bicarbonates, stable compounds, which are then being washed out into river systems, out to the ocean, where it's locked up for geological time. So that's tens to hundreds of thousands of years.
So what happens is the crushed rock is spread across the land to maximize its exposure to the elements. When it rains, there's a chemical reaction between the rock and the rainwater, which solidifies the carbon and removes it from the atmosphere.
We're early stages, so I don't know how efficient it is, but looking at the science and the data they've got, I think it will have a long-term benefits to their soil.
How much do you think the agricultural industry feels perhaps unfairly targeted for its climate change emissions? And what do you think that this will do to help change that?
I think farming has been looked at as a soft target and maybe not that particularly good at defending itself as well. But food production must continue. It's the most important industry around. And I think using a product like this will surely have a positive benefit to everyone.
How much of a game changer is this in terms of locking carbon out of the atmosphere and into the ground?
It's transformative. I think it's the most scalable technology. We have, huge deposits of rock globally ready to go, and we have farmlands in every single continent. And all of that means that we could achieve, billions of tons of removal on the very fast timescale for the climate.
The team behind it say there's a huge supply of basalt available in quarries which can be spread on farmland across Scotland and beyond. They believe their magic dust can play a huge part in the rush to decarbonise our economy.
Many of us lead hectic lives, dashing from one place to another. But whether you're at work, in the supermarket or at home, have you ever really thought about how spaces are designed? Welcome to a building within a building. At UCL's Pearl Lab, the way that people move and interact with their surroundings can be observed, measured and analysed under controlled conditions. The aim is to help create better real buildings as a result. Lighting, acoustics and even smells can be tweaked. Today's experiment is monitoring how people move through spaces in an art gallery situation, and with a few challenges thrown in, the decisions that they make along the way. As well as the 18 cameras that are monitoring the way that people move around the space, there are a lot of wearables, including this EEG device that's got 64 sensors on it. That's monitoring brain activity. And then over here, this eye tracking device monitors your eye movements. It'll record them on the phone as well. So whatever you're looking at here will be seen on the device. And this is called the bright light frontal. It shines light into the head to see the blood flow, to see if somebody's being stimulated by the things that they're seeing around them. It's this mixture of eyes, brains and heart rates that will help architects and their designers plan the buildings of tomorrow. Neuroarchitecture is the concept of designing efficient environments based not only on technical parameters, ergonomics and environmental factors, but also on emotion, happiness and well-being. The aim is also to create more diverse environments, ones that are good for more people.
Right now, designers try and come up with a building that will work well, but actually, to do that, you want to know about the people, how they feel, what's happening in their body. To really create the best possible buildings for a healthier society, a more sustainable future, we need that extra information.
Buildings and how they're expected to be used are often planned with the help of a digital twin. That's a virtual model of them. These are data hungry, but an important way of predicting issues before a brick is even laid.
One of the things that we're aiming to do here today is to take simulation to a next level, because simulation typically assumes that all humans are the same. We're able to kind of bring in what humans are good at together with an AI tool that, for example, can treat large data sets and really identify things in it that we might not immediately be aware of.
The participants today were from a mix of the worlds of architecture, transport, AI, property, video game design, dance, museums, BBC tech shows, and more. We're being told there are no instructions. Just walk around, talk to people if you want to. Nobody seems to be talking to each other. There are also these envelopes. It says open when instructed. I'm wanting to open it now. I want to be rebellious, but no, it might ruin it. I won't. I'm interested. You give people no instructions. They've all gathered there watching something. A couple of people go wandering off. I want to go and wander off there. For no particular purpose. Participant ID 64. Order of screens to visit, starting top left and working down each column. What? I've got to visit all of those screens? OK, let's get started. Right. Number 11 first.
Hello everybody, well done, you've completed the task.
That was fascinating in itself, never mind the data that's being collected, but just to see the way that people behave. First of all, nobody spoke to each other. Then we started chatting a bit. Well, I started talking to people a bit. We were all quite relaxed. As soon as we had a task to do, it immediately got competitive and quite manic. And then going round in circles, you start to feel quite strange. I'm wondering how all of that came across in the measurements, especially for the people that were having their brains tracked. The findings will become part of a database that'll be drawn on for years. But can anything be gleaned a week on from the experiment?
There were things where people did extra things we not expected. So one of those was to sort of break out of the space. And the tracking did extend to some extent. I mean, I think that's telling us something interesting. Who decided to break the rules and who decided to stick within the bounds? People came up with like cognitive offloading on the day. They kind of used tools to help them remember things that we hadn't anticipated, which is what happens in real life. So it'll be interesting to see who does what and how predictable people are. Can you predict who's going to be, naughty or who's going to be rigidly stick to the rules?
This experiment marks the beginning of a journey of discovery. The architects and neuroscientists will continue to learn more from the data about how we interact with spaces in the real world. And this could eventually influence the design and feel of the places that we inhabit. And that's it from UCL's Pearl Labs. Thanks for watching. We'll be back next week. Bye-bye.